Okay, wear on these clutches. The wear predominantly, almost exclusively really, is this surface, and the companion friction that rides on that, where it can get gunked up. That is a big, those are the big places or points of wear. So it's important to get a good amount of oil down here and back here. As I said, this is all very passive. It's just oil being flung into this thing and then it being distributed through these channels. These little wings also help catch some of the oil and direct it in. So the oil is, and the main hub here, is delivered through these holes. But the oil back here is even more passive, because the oil traveling down these channels is not going to run directly onto this down here. It is going to get flung off. Remember, this is just turning at a huge speed. The centrifugal force is just going to take that oil and just want to shed it right off. So back here, it's really the oil. Some of it will get there as long as it's slightly engaged. You'll get a little bit drooling off, or off between the crack and out there. But once you disengage it, the oil's just going straight out. But the oil being by your thrust adapter being flung around inside here, this probably becomes a very misty kind of area here, because it's spraying out. This thing's turning this way. It's spraying out on here. It's hitting a post. It's flying around. So incidentally, some ends up getting down in there. The posts have a taper to them. Most of that is probably due to structural reasons. But the other thing that incidental could be that no matter how fast this is spinning, with oil this spraying against this thing, there will be a film of oil on here. And that can migrate down. And this is another area where I did a modification, and that is dealing with that idea of this film of oil, however small that is. And this thing's spinning. When anything's traveling through air, water, any medium, there's the backside, opposite the direction of travel, there'll be a low pressure area. And so what I did was I grooved the backside of these, because this is the direction it's turning. And I grooved it with this kind of like small grinder type. And this is what is this? It's a Dremel offcut, a very fine one. And I could just score that, just to give it a light score, just so any of the oil there I could collect to get down there. And it did seem to make a difference. It did seem to deliver a good amount of oil. And after that 7K, and again, like I say, that's not the proof, absolute proof, but it looks pretty good to me. So this was another little modification, and you know, it's within easy reach. It's not complicated if somebody wants to do that themselves. The other thing, the clunk, to get rid of the clunk, and talking about wear, is the basket itself. This is a big, expensive piece. And these these frictions, it's not lined up, has to be lined up correctly, fit within here. And so each of these is captured by a little area down here. And so there is some tolerance here that these things have a bit of room to move. It just is necessary. It can't be, they have to slide within this, because when you push the clutch in, these tabs are engaged here and they have to slide. But one of the consequences of use and the clunk is that this will not show up here, is you get indentations along here. I can run my finger, this is a used one, and there are definitely, you can feel this kind of bumpy surface from each one of these slamming against this aluminum casting here. And one of the things you can see right away is that, oh man, is that ever lumpy. You feel the other side, oh, it's like a baby's bottom. Why is that? Why is one side fully dented and the other side smooth? The clunk. Remember, this thing is turning. This is the part attached to your engine, and this part's attached to your transmission. So when you're in neutral and you drop it into first, this is, yeah, it's slopping around in there because the RPMs on a bike are not steady. They vary up and down a bit. So this is kind of moving around in there a bit. But as soon as it comes to a dead stop with it spinning this way and your transmission not, bang, it goes against that side. And the buildup of those small little indentations start to restrict the plates from being able to slide along. We need that separation, but those little indentations create some resistance to that. So this is one of these kind of things that's self-perpetuating. The more the clunk happens, the deeper these get, the less those are going to be able to come apart. So there's another reason to try and address the clunk, or just be aware of it, is you're going to get a lot of wear there. So we've got, I did new oil holes. I did some rearrangement here. Oh, there was one curiosity I just want to point out with oil holes. And that was, I was really having trouble with this feeding this number, there was 7 millimeter, this kind of space. There was just so much oil. And again, because it was directly below where all this oil is pouring in, I couldn't seem to get a small enough hole. So what I actually found worked was the new hole I made was I eliminated that completely, and I put it between two of these channels. There it is right there. And it worked fine because all this surface in here is covered with a film of oil that's being shed off. And so enough got into that hole to oil that little environment in there. It worked okay. So that's one kind of little oddity. I just want to point that out. So one of the other things I came up with that will be controversial is reading about, again, coming back to these big heavy equipment clutches. And I believe it was a lot of, there's a lot of good information if you search out like grad students doing their master's papers. I couldn't understand the mathematics. I don't know that stuff. But the general kind of ideas, concepts behind things, yes, those are quite accessible. And I think it was a Finnish paper, a young fellow, and he was pointing out that there are, and what the advantages are of oil, different quantities of oil delivered dependent on what the clutch function is. Is it wide open? Are you trying to break the plates? Have the plates broken? So there was an advantage to having specific amounts during specific times, instead of this just constant flow all the time. So I thought, oh, okay, let me think about that. And what I came up with was, knowing that the slave cylinder moves 2 millimeters. That's how much this is moving in to the drive shaft. 2 millimeters is all. It's really small, but there's a tremendous amount of pressure. This spring and arrangement is very, very stiff, very strong. So I've got 2 millimeters of movement here. How much space is there in total when, say, the clutch is not disengaged, when it is engaged? It's just, you're just riding down the highway. And so what I did was I just keep putting washers on this, because the idea was I wanted to find out when did this bump into that. And I kept putting washers on until I found that when I pulled in the clutch, just as I got to the bar, just before the bar, I could feel it click, click, and you could literally hear it as this was hitting the shaft. And that I came out to about 4.5 millimeters. So the total space between your drive shaft and the back of your thrust adapter is about 4.5 millimeters. So what I did, and this is the controversial part, is I got a washer, and it was about 2.5 millimeters, and I put it on there. I just put it loose and rode with it, and it did work. What I was attempting to do is just shut the oil off at that last moment, so that as the clutch is spinning, it can shed that oil, and then the plates would break. It worked okay, or worked fine actually with this arrangement. But the problem was, we're back to that kind of visceral thing, is I could eventually start hearing a buzzing, and it was the washer rotating around on here. And as the longer it was on there, the more the edges of the hole got worn down. So it started to wobble more and more, because as it wobbled, it's kind of the holes, the ends of the holes started to flare, and so it got more and more exaggerated. So what I ended up doing was actually fusing this to the back of this. There's a nice amount of space in there to hold some, and I used this same material, this JB Weld, which is so far stood up really well. So now what I've got is I've got a pin that when I pull the clutch in, it moves and it shuts off all the oil. Now, I don't know what rotation this would have to be at to get rid of all oil, but it would have to probably be fantastic. There's always going to be some clinging oil to it, but I still didn't know how it was going to work. And it appears to be working just fine. What I would do every time, and with this time, which you didn't see because the video didn't get uploaded, but there was plenty of oil in here. And for consistency's sake, what I would do is when I came back from a test run, I would stop, I would pull the clutch in, and basically at this point I'd found that I had to kind of count to 2 or 3. So I'd pull the clutch in, 1, 2, 3, and then I could drop it into gear, and there was no clacking, no nothing. Sometimes actually it wouldn't go into gear because everything was dead stopped, and where it had stopped, the gears weren't meshing. They were slightly off like that. I just have to let the clutch out just a little bit and then click, and then it's okay. But there appears to be enough oil, and also as soon as you start to release, this is already starting to pull away a little bit, so oil is already beginning to spew in there even before it's back to its kind of resting spot. But I know this is where a lot of controversy will happen, like, whoa, how can you cut that oil off in there? Well, it's momentary, and it's in a state where there is no need for friction. There still seems to be plenty of oil on there to not show any pronounced wear. Like I said, one of the things I did find while playing with this is when there was not enough oil or too much, sometimes, like when I was using those rubber bands, I put bands on everything. But what happened then was there was constant pressure on this back plate, too much. I was overdoing the allotment of the 0.125 spacing there. But the way you could tell with wear was when you took this off, you could literally see the little squares of the pads, but there was black in between each of them. And that black was wear from the aluminum here, and same here. So my guide was no black. And yesterday when I took it apart, there was no black. So that's showing there's still enough oil with this. And it's not always, I'm not sure why, but there are times where sitting for a long time, oil can seem to pool in here. So when I pull it in, anticipating a light change, it took actually longer for the oil to shed. I've actually learned that, okay, I've only got a certain amount of time I can sit before I've got to wait longer to shed the oil. But, you know, if you ever, I found that if I was ever reminiscent and missed the clunk, all I had to do was just pull the clutch in and try and drop into first clunk. The clunk was still there, even with this and cutting off the oil. Granted, it's only momentary, but I'd pull it in, drop it into first clunk. So the fluid coupling was still happening. Let's see here. Trying not to forget too much. So this is, again, I'm not saying in any way implying that anybody should try this or suggesting this is the only way. There's a lot of remnants, relics here from my progression of trying different things. But for an overall understanding of what's going on, personally, I like to understand what's going on, even if I can't see it. There are other indicators like your clutch, like the sounds, like the feel when you let it out. But I will make a suggestion that if anybody's interested, like I'm tired, you know, like I said, over 150 times into this, I'm done with it. But if I were to do it again, I would approach it with probably one of the first things I would do would be this, just to see, without changing the size of the original oil holes. My suspicion is that it would probably still be too much oil. I would be tempted to go with the pin that came with the 1300s had two grooves. This was BMW trying to address what they thought was the need for more and more oil. It started out with a little aluminum plug that was stuck in the end of the drive shaft that had a little flat spot. Then I think they went to one with two flat spots, and that didn't work. And then they went did this pin with one channel, and then they decided, oh, it's still not enough. We're still having problems. We need more oil. So they went with two slots to deliver more oil. Now, backing up here, I started off approaching this thinking, oh, it needs more oil. The 2009 K1300s had the old oil pump. In the middle, I think, of 2010, BMW introduced an oil pump with 25% more capacity. Again, I'm sure it had a good effect on the engine, but it might also have been an attempt to help address with this ongoing thing of more oil in the clutch. So anyways, yes, I upgraded. I put that pump in there, and again, that was early on. I discovered now I probably wouldn't bother. But back to suggestions, I would probably, if I were going to do it again, I would get a single pin. Get your washer. This washer, I had to find a washer, the right thickness. I actually had to hand emery paper it down a bit, and I put it on a lathe to get it the right diameter of the existing bearing. because this bearing and the slave that's out here are oiled passively, again by just the atmosphere within here and oil traveling through here, into here, and through there. So you do not want a washer that blocks any of this off. But so that would be probably the first thing I would try if I were going to redo this. Don't change anything, try this first. These things can have a lot of wear, so I would probably try this. Again, this is a pretty straightforward, it's not a hard thing to do, and that would help deliver the oil back to this back plate. The other thing would be to, if you wanted just to do that, straighten it, get rid of that hump. That way, you know, there's kind of even oil going through the whole thing. Patrick Hoffman took a K1300 clutch apart, and it was absolutely bone dry everywhere. And he was amazed that it hadn't burned itself out. But the plates that were, the friction plates that were against here and here were all gunked up, and these were showing signs of wear. But internally, it looked new, as he pointed out. So the amount of oil within here is not as critical as it is on the ends. And these are the areas to focus on for reducing oil. So at this point, I guess that would be my suggestion, is do this if somebody wants to do it. Do this. As far as the grooving, that's getting a little beyond at this point. If somebody wants to see what I've done, we can, in the comments, somebody could ask. Let's see. You can pick a lot of this stuff up used on eBay, and that's what I did. I mean, here are some other iterations of these steels. Here's one where it's just gone crazy. Like you can see, that side was pretty dry, and then that side was soaking wet. That was maybe on the borderline between where the oil hits here and within that channel. Okay, I think that might be it. I haven't got a script because I do not know how to edit these things and splice things together. I don't do it, I do it very rarely, so I'm not motivated to learn how. Just one other, this is more of a maintenance thing if you guys are taking this apart, and it may have been apparent to most, but I made a mistake, and that is when kind of reattaching this thing, I would crank down quite a ways on these screws and then go to the other. And what you're doing when you crank down on those screws is you're depressing, you're kind of preloading this, or loading this spring up. And I actually stripped one of the posts in one of these pieces that I bought. So just as a suggestion, just kind of go tight, and then go tight, just finger tight, keep doing it until you need your torque wrench. And speaking of torque wrench, the side casing on the bike, on the clutch side there, a lot of people have talked about, the gasket and the screws, don't reuse them. Well, in the over 150 times I took this apart, I've just used 2 sets of screws and 2 gaskets. Those screws are meant to be used only once, and that's because they're tightened down to 3 Newton meters, and then you add 90 degrees to that, and that 90 degrees is stretching that screw a bit. So the screws, once they've been like that, it's not a good idea to reuse them again. I suppose they could strip, and they could also break. But I bought a little dedicated 3 Newton meter torque wrench. And so I would do up all those, I don't know how many screws there are, 20, 21 something. I would just do those up to 3 Newton meters, not beyond that. And as far as the gasket goes, like I say, I never took the gasket off. I would leave it on the bike all the time and oil it before I put the side back on. So it's, yes, according to factory, you know, the specs and all that, you're supposed to replace it all the time. But I got through that on my 7000. I did notice one area where there was a bit of oil. I couldn't even see oil. It's more like a mist, a little film. And I just simply hand increased the tightness of those bolts around there. So personally, I would offer up, don't worry about that. I would not hesitate to use them. One of the other things that I would completely endorse, and it's a suggestion by a number of people to deal with this clunk, is forget about everything I've said here and never have the clutch out and pull it in and drop into gear. Never go from neutral into first. When you start the bike up, pull the clutch in, put it in first, start the bike. And when you come to a stop, just pull the clutch in, have it in first. The real wear potential, or the only potential, is really this bearing and probably the slave would be with that amount of use. Also, if you're doing a lot of city riding where it's necessary to sit at a light with the clutch in, you may develop a hand like Popeye's arms. But otherwise, it's a really good suggestion, an approach, a legitimate approach to get rid of that. Then aesthetically, when you come to a stoplight and you take off from that stoplight, nobody's going to be turning their head to hear what that huge whack was. And these are certainly robust enough to stand up. They're also a lot cheaper to replace than dealing with the basket or even your clutch itself. So that's something that's I would endorse doing, and I may do that myself if I were to go back to the original. Just forget that. But this has been done. It's probably a little edifying, I hope. It was satisfying for me to arrive at something that works. It was difficult because anytime you're trying to change something that's already designed with certain parameters and you try and introduce other ones, there was no way I could introduce that spacing. That would have been the very first thing to do. That would have been wonderful. But can't be done, so it had to be some kind of funky alternatives. So I hope you get something out of this, at least a little insight into the clutch on your bike. If you have any questions, feel free to ask, and yeah, happy riding.